Friends, welcome to San Academy Pallikaranai class 10 mathematics. We are going to learn in this part 3 surface areas and volumes. So how the combination of figures we have seen already, formulas we have learned in first part 1 and part 2, what are the combinations where you have to concentrate more on the when the solid figure, two solid figures are combined. Okay, now let me see the what are the sums based on the exercise 13.2. So now first you see a solid toy is in the form of a hemisphere. It is in the form of a hemisphere surmounted by a right circle. Surmounted means on the top of the hemisphere by a right circular cone. If height of the cone is 4 centimeter, the cone is 4 and diameter of the base is 6 centimeter, then diameter means radius will be 3 centimeter. Okay. Then find the volume of the toy. What is the volume of this toy and surface area of the toy? Okay, whenever the surface area means only you are going to cover upper part, not inside and out. So the CS of hemisphere plus CS of a cone you should add it. Okay. For CSA we need L for cone, pi r L formula. Then L, finding L, how to find? Base radius is there, height is there. Base radius is 3, height is 4. Then will be 5 is the, by using the right angle triangular formula, Pythagoras theorem, we can find out the L. So you got the L. Now what is the CSA of a toy? Means CSA of a hemisphere plus CS of a cone. What is the CS of hemisphere? 1 by 3 pi r square. For CS of hemisphere is 2 pi r square. Okay, and then this is pi r L. So now pi r you can take outside, L plus 2r. What is the r here? Substitute the values, then you multiply, you will get the answer for it. Same way, volume they are asking. Volume is weight. So volume of a hemisphere plus volume of a cone. What is the volume of a hemisphere? 1 by 3 pi r square h. Okay, cone is 1 by 3 pi r square h. Hemisphere is 4 by 2 by 3 pi r cube. So if you substituted, you can take out or you can do separately and then also you can do it. Whatever your wish, that is no problem. So 1 by 3 pi r cube, pi r square is a common. So h plus 2r, h is will be here height of the cone will be 3. So it's given clearly height of the cone is 4 and 2 into r is 3. Then you will do it, you will get the answer of the volume of the cone. Okay, where you means calculation part you should be so much you should struggle. So should be careful while doing the multiply and division. Okay. Now let me see the one more sum. It's a very interesting sum. In this, from a solid cylinder whose height is 2.4. What is the height of a cylinder? 2.4. And then diameter is 1.4. Then radius will be half of the diameter. Then 0.7. A conical cavity of a same height and same diameter is hollowed out. Hollowed out means taken out. This means this part is taken out. Then whenever the taken out, find the TSA of a remaining solid. See, the TSA means don't think TSA formula we have to use. Here surface area only we should use. Means we are taking out this CSA. Whenever this CSA is coming, you should add it. Then volume only you should remove it. Okay, we are taking out means the volume of that one we remove. But here CSA means we hollowed out means that shape we hollowed. That surface area will be that part. Then here diameter is radius is 0.7 because diameter is 1.4 and height of the cylinder is 2.4 given, right? Height of a cone is 2.4 given. Okay, cone will be equal to cylinder height only. Yes. Now what is the CSA of a remaining solid? CSA plus area of the bottom of the cylinder, CSA of a cylinder plus area of the bottom of the cylinder and CSA of a cone, surface of conical cavity. So 2 pi RH plus pi r square plus pi rl. So pi r they are taken outside, 2h plus r plus h, substitute the value, L value no, by using the right angle triangle Pythagoras theorem, you will get L as a 2.5. Then you add it and then multiply, you will get the answer is 17.6. It's nearly is 17.6, nearly is 18 centimeter square. Then TSA will be 18 centimeter square. Okay. So now one more sum we'll see. It's a volume here. So now if you see the volume, we have done the before sum is CSC. A gulab jamun contains sugar syrup about 30% of the volume. Volume of the water. Volume. Find approximately how much syrup would be found in 45 gulab jamuns. Okay. A gulab jamun contains sugar syrup up to about 30% of its volume. In the total volume, one gulab jamun is containing 30%. Then what is, if it is 45 gulab jamuns, what is the volume of the syrup? Okay, is shaped like a cylinder. The gulab jam is, listen carefully, shaped like a cylinder with two hemispheres. So this part is very important. It's like a gulab jam is cylinder with two hemispheres. So here like this. So gulab jam is like this. Okay. Then this is cylinder, middle part is cylinder, and these two parts are hemisphere. These two parts are hemisphere. This part is cylinder. Clear? Okay. So now this part is cylinder, this part is hemisphere. So now what happened? The gulab jam. So it is shaped. Then first you find out the one gulab jam. This one. So what is the volume they given here is what is given here? Diameter is 2.8 and then height length of that gulab jam is 5. Then listen here. This total is 5. Then this is 2.8 is the radius, the diameter. Then 1.4 will be the radius. Then this radius will be whenever hemisphere, that radius will be equal to depth of the that bowl, means depth of the hemisphere, means h. The r equal to h, remember, r equal to h. So 1.4 will be equal to the radius. Then how many 1.4 this side also, 1.4 this side also. Then 2.8 we should minus with in the 5. Then the height of the cylinder will be 2.2. Then use 2 times of volume of hemisphere. Then 2 hemispheres are there. Plus 1 time of volume of cylinder. If you use this one, you will get the answer is 25.07. Okay. Now how many gulab jams are there? One gulab jam is 25.07. Then how many gulab jams? 245 gulab jams. Multiply by 45. Then 1128.15 centimeter cube will. Then each is having 30%. Then total is 45 gulab jam. One is having 30%, means then 45 gulab jams are having 338.45 centimeter cube volume of a syrup will be there in that 45 gulab jams. Yes, clear? Yes, very good. Now next one also same interesting here, three solid shapes. Okay, because cylinder, sphere, cone, hemisphere, cone. Then yeah, this is also very important question for your board exam point of view. Okay, let me see what is there in this. Okay, now what they given here? First read the question. First read the question. What is it? Hmm? What is the given? We'll read the question. A solid consists of a right circular cone. A solid, this is a solid, consists of a right circular cone 120 centimeter height and radius, this height is 120 centimeter. Cone is 120 centimeter and radius is 60 centimeter. Okay, and then standing on a hemisphere. Where is the cone is there? On the hemisphere of the radius 60 centimeter. That also 60 centimeter. Placed this both the solid to upright in a right circular cylinder. This figure they placed in the right circular cylinder full of water such that it touches the bottom. Touches the bottom. Cylinder is, so now when you put any on full of water is a bucket. When you throw any stone, what happens? Water will come any weight if you put it in the water will be fall to come outside. So here, when you are putting this cone and hemisphere toy, solid figure, the water is there in the cylinder, it will overflow outside because of the weight. Then what is the displacement? Means this is called displacement, you know. So find the volume of water left in the cylinder if the radius of the cylinder is 60 and height is 180. The given height is 180 and then this is 60. So as we know that, first find out the volume of the hemisphere plus cone. So volume of the hemisphere will be water flow is a cylinder is volume of a cylinder is pi r square h. Then you will get 1000. If you do this pi into 3600 180, you let it be like that because this volume equal to that volume. Then volume of cone plus volume of hemisphere. What is the volume of cone? 1 by 3 pi r square h. Volume of hemisphere 2 by 3 pi r cube. If you do, you will get this also 4 by 3 pi 16. This volume, that volume, if you equate left in the water, this volume minus that volume. Yeah, you can minus. So if you minus, you'll get the answer is 1.131 meter cube approximately. Volume of that toy, volume of cylinder minus volume of that hemisphere minus volume of cone. You will get the answer is 1.131 meter cube. Okay, now what left in the water is, now left in the water 1.131 meter. So okay, this is a base on some exercise or exercise 13.2. They are all very important sums. I hope you all understood. Thank you, students.